All right, last forest type we want to cover here, and then I'm going to just take this opportunity to wrap up some of the broader concepts about environmental action or interactions and how they influence what we see in terms of forests. So our last forest type is boreal forests. These tend to be northern forests. They are characterized by a long winter, harsh low temperatures, and they generally are conifer dominated. One of the reasons for that is when you have sustained winter temperatures around minus 30 C, you tend to, for the most part, broadleaf species will not persist well in those parts of the world. So, like I said, we're talking about northern forests. So much of Scandinavia, Siberia, and the Canadian Shield. If you haven't been to those parts of the world, my guess is that where you might be most familiar with these kinds of forests is in Alaska. That's actually the only time that I've been to boreal forests, and actually it's the only time that I've been in the Arctic. So, like I say, long winters, harsh winter temperatures, the ground often freezes within these forests, and many of them are actually underlaid by permafrost. Now, here's something that's an example of the transition into boreal forests. This is actually Acadian forests, which are pretty typical of Maine. These are wet forests. They have a long, harsh winter, and it's cold. The ground can freeze there, but it's not necessarily underlaid by permafrost. Now, what you see here is a dominance of conifers, true firs, abies, and picea, the spruce, several species of spruce. These are economically important. The forests tend to grow more slowly, but they produce a lot of valuable timber and fiber. As I mentioned, these ones are very wet, and it can be very cold, and the transition of temperature is really what's going to drive conifer dominance here and structure that's typical of boreal forests. Here's another example. If you've been to Minnesota or the upper Midwest, you may have seen some of this, especially as you go from the south of Minnesota into the north and beyond that into Canada. You'll see a transition from broadleaf dominated forests, like you're seeing here in this photo, to conifer dominated forests, like I say, pine, spruce, and fir. Now, one thing that I want to take the time to emphasize here is that cold temperatures, broadly speaking, limit forest dominance in many parts of the world. And the importance of cold temperature is not limited to the distribution of boreal forests only. You can see this in mountain ranges, in tall mountain ranges throughout the world. This is an example from the Alps. This is the French Alps. And what you can see, it's somewhat hidden within these photographs, but you can see the limit to tree distribution overall. Eventually, it becomes too cold even for conifers to establish and be maintained as forests within these regions, just as it does in the north. And these two photographs show that there are some broadleaf species that are going to occur that can persist at somewhat lower elevations. These are birch species. They're adapted to the very cold conditions here in the winter, but eventually they reach their limits as well. Look elsewhere in the world. This is from Mexico. That's Volcan Popocatépetl there in the background. Even though this is subtropical, it's right on the kind of border of the tropical, subtropical montane forest, it's still very cold, above 15,000 feet. This is an 18,000 foot volcano. It's really tall. And these that limits forest distribution. And in fact, even below the elevation that you're seeing here, it limits the distribution of broadleaf species. And here's one last example. It's not just elevation influencing temperature. Aspect also influences temperature. So the direction and degree of slope on any mountain influences the amount of solar radiation that is being intercepted. So this is from the South Island of New Zealand, Arthur National Park. And there are a couple things that you're seeing here. One is there's distribution to tree, limitation to tree distribution that is driven by cold temperatures. There is a tree line, and above that, forests do not persist. But also hidden within this photograph is the importance of aspect. In the northern hemisphere, south-facing aspects are warmer. They will tend to favor warmer species that are adapted to warmer conditions, and the tree line will actually occur at higher elevations. The opposite is true in the northern hemisphere for north-facing slopes. Those slopes intercept less solar radiation, and tree line will be lower because it's, for every foot of elevation, it's actually colder. Now in the southern hemisphere, because it's the southern hemisphere, those relationships are shifted. So here we're looking at south-facing slopes, which are the colder slopes. This is where you can find the really good ice to climb. I know that's why you're here listening to this video. You want to know where can you find the good ice? Well, it's on the south-facing slopes in the southern hemisphere and north-facing slopes in the northern hemisphere. And anyway, and point being, the aspect is still modifying this, these kinds of relationships in very cold conditions. Actually, it modifies relationships related to heat and moisture no matter where you look, but it is pretty obvious at the high elevations. Here's just another little thing also from New Zealand. This is, these forests are not actually dominated by conifers because conifers are not as well adapted to these high elevations. This is Nothofagus. It walks, quacks, talks, whatever, like a conifer. It actually doesn't do any of those things because trees don't do any of that. But anyway, ecologically, it's got a lot of similarities to high elevation conifers. It's another example of convergent evolution. So just to pull this all back, because now we're finished with our tour of the major forest types, I just want to emphasize one more time how important temperature and precipitation are in influencing the distribution of forest types. You can see this at many different scales. You can see it at relatively local scales, say landscapes within California, like Sierra Nevada. You can see it when you look from the equator to the Arctic, or vice versa, to the Antarctic. Temperature and precipitation are going to interact to determine what kind of vegetation is dominating there, grasslands versus forest, or some other ecosystem type, as well as what kind of trees, broadly speaking, are going to dominate a particular forest. Will it be broadleaf? Will it be evergreen? Or excuse me, conifer? Will it be deciduous or evergreen, and so forth. Temperature, precipitation, including